Okay, friends, good morning. This is Suraj Patel and welcome to Math Chef YouTube channel. Okay, today is the in previous class we have discussed about the problems based on the circular functions. Problems based on the circular functions. The maximum value, minimum value. Then we have discovered the figure out the domain, range. Okay, sir. Some behavior of the functions at different angles in previous class. Today we will the graphical representation how the all trigonometric functions is represented on the the coordinates plane. So in the graphical plane. Here you know what the graph means. Graph is a mathematical formulation, mathematical pictorialization between the two perpendicular real lines. Something this is the graph. Okay. This is the R1, real number 1, this is the real number 2, group of real number. You can tell this one, you can tell this one, whatever it may be. This is the graphical. It means in the graph we can see how the function, algebraic functions sees in the graph. Okay. Similarly, there are 6 trigonometric functions. There are 6 trigonometric functions. The first one is graph of the sine function. Graph of the sine function. Sine function. Already you know in the period. Period means you getting the same values at a different constant angles. Period is as you get the function we have same give the same value rotating with a complete circle or complete rotation. That's called rotation. So sine anyway sine x have period 2. So sine of x plus 2 pi is equal to sine of x. This here you can discover the if L 2x is equal to 2 pi, then x becomes pi. The period. Or you can tell also if y is equal to sin x plus 2 pi, this is equal to sine of x. Similarly, if y is equal to 2x, so this should be 2 pi only. This you can write 2 pi, so this becomes 4 pi. 4 pi. This you should write for 2x is equal to 2 pi, then x becomes pi. So this should be equal to pi then. So then this is equal to sine 2x. In general you can write it. This then here just get the clarification how the function behaves with the value of. If you want more clarification here, so you can write this in form also. Here you can take sine of 2x plus 2 pi is equal to, we should get sine of 2x. So this period becomes sine of 2 taken outside, the x becomes 2 pi by 2. So this becomes sine of 2x. Similarly, sine of 3x plus 2 pi. You get should sine of 3x. So if taken 3 outside, what you will have 3x plus 2 pi by 3. Okay, so is equal to 3x. Sine with sine. Okay. This in general, okay. And this in general you can write y is equal to sine of bx plus 2 pi is equal to sine of bx. If I taken outside sine of b x plus 2 pi by b. Therefore by period the period of sin x, the period of sin x, sin bx is equal to b of x is equal to 2 pi by as b of bx is implies 2 pi by b. Okay, sir. For period is okay, sir, plus or minus 2. Okay, sine we have values. Sine of 0 is equal to sine of plus or minus pi plus or minus 2 pi, means any integers. Here you can write b belongs to I or bx as implies, then period becomes 2 pi by mod of b. Head to the books. Okay, both is the period. Okay, sir. If you want to find out the period of the bx, then have to divide by the value by 2 pi by b. This is equal for same for the sin theta and cos theta. Okay, let's check the graph. The graph would be like this. Let's take the graph. Domain of the sin x, y is equal to sin x. Okay, right here only. Y is equal to sin x is a function. Okay, sir. Where x belongs to domain belongs to R. On range, so y is minus 1 is less than or equal to 1 and less than or equal to 1. A range of function. Okay, this is the condition. So domain line is domain line is okay. You are taking this one, I will take here. This is the range. Okay, sir. Range of sin x. Okay, this is the positive side. This is the negative side. This is the domain of the sin x. This is the positive side and this is the negative side. Okay, you know already the value of the and this is the 0. Okay, this is the pi by 4. This is the pi by 2. This is the and is the 3 pi by 2. Is it? What is the next value? And this is the pi. And this is the just take the corresponding values in here books. Pi by 6, pi by 2, pi by 2, pi and 3 pi by 2. We'll take this one, maximum values. And take the direct. Pi by 4, pi by 2, 45. This is 45 degree, this is 90 degree, this is 135. What becomes pi by 2 plus pi by 4? Okay, pi by 2 plus pi by 4 becomes 5 pi by 4. 5 pi by 4. This is pi. This is 3 pi by 2. This is 2 pi. Similarly, here also minus pi by 4 minus pi by 2 minus pi by 4 minus pi minus 3 pi by 2 minus 2 pi. Okay. Pi by 4. Okay. Now for pi by 2 it has value 1. Okay sir. For pi by 2 it has value 0. Okay, so 1 by 2. This is the 1 and this is the minus 1. Okay. This is the 0.5 or 1 by 2. This is the 1 by 2. Okay. And this is also again, okay, sir, this is also 1 by 2. Then this becomes 0 here and this becomes minus 1. This becomes minus 1 and this becomes let's take this becomes 2 pi. Okay. This is not necessary, it can be. So this function behaves like that. Okay, reaches and 0 and again comes to the minus and goes to the 0. Okay. This is the range of the function. Okay. This is the range of the function. Okay. This is called y is equal to sine of x with the period 2 pi. Period is equal to 2 pi. Similarly, this is behaves like that. This is minus 1. This is 0. Okay. This is minus 2 pi. And this is positive 1. Okay. So this becomes, okay, goes to here and reaches 0 and comes here and reaches 0. And the graph of the sine functions we have like that. Okay, sir. 0 has a 0 value, pi by 2 have 1 by 2 value, pi by 2 has the positive 1. Again at pi it has 0 value. Again 3 pi by 2 is the minus 1 value. Okay, sir. Then 2 pi it has 0 value. Similarly for the negative. This is the graph for the function sin x. Okay, sine function. The graph for the sine function. Next. Next, y is equal to cosine. Okay, sir. This is the cosine. Cosine. Okay, sir. Here y is equal to cos of x. Again, period is 2 pi. Okay. Period is 2 pi. Then what is the sir? If then in general what we call the period. Okay, sir. The period of bx, cos of bx you can write. Cos of bx is equal to 2 pi by mod of b. Okay, sir. You write and b belongs to integer. Okay. If period is same, then again what is the cos? Cos is 0 is the reverse odd or the even function. Then how will tell? And this is the okay. I will take this one. This is the range again. Okay, sir. Domain is okay, sir. Domain of cos x is domain of f is equal to domain of y is equal to belongs to R. Okay, and the range, okay, sir. -1 is less than or equal to y less than or equal to 1. Y is the cos x. This is the domain. This is the range. This is the 0 and this is the negative side. Okay, sir. The 0 is the pi by 2. This is the pi. This is the 3 pi by 2. This is 2 pi. Okay, sir. I'm just considering, and this becomes minus pi by 2. This becomes minus pi, and this becomes minus 3 pi by 2, and this becomes minus 2 pi. Okay, sir. Here for cos 0 we have the value 1. Okay, sir. For cos 0, okay, sir, negative value 1. Cos minus pi. Okay. For 90 we have the 0. Again cos pi have the minus 1. For 3 pi have the 0. Again for 2 pi. Okay. Again for 2 pi have the value 1. Okay. Just draw the diagram. It starts from here and comes to the 0 and again goes to the minus 1. Again comes to the 0. Again goes to the 1 plus 1. Okay, sir. This function becomes y is equal to cos of x with the period 2 pi. Okay, sir. Here again for 9 1 by 2 becomes 0. For minus pi it becomes 1. Okay, sir. Again pi by 2 becomes 0. Again for the okay, sir, minus pi 2 it becomes plus 1. Okay, sir. Becomes minus 1. Okay. This is the okay. Okay. This is the function, the graph of the cos x. Yes. We will see afterwards the multiple angles 2x or 1 by 2x, 0.5x, something else. But here with the period, okay, this is only for the period 2 pi. Okay, we solve the example based on this question later words. Okay. Next is graph of the tangent function. Graph of the tangent function. Graph of the tangent function. Tangent. Okay, so here y is equal to tangent of okay, not tangent of x, is the tan of x. Okay, again here the domain, okay, this is sin of x by cos of x. Okay, sir. See here cos of x is not equal to 0. Condition applies. Okay, sir. Because 1 by 0 is not defined. Okay, cos of 0 means what? Okay, sir. Cos of 0 means is equal to, okay, sir, 2n plus r1 by pi by 2. Therefore, the domain is, okay, sir, the domain becomes r minus, okay, sir, 2n plus 1 into pi by 2. 2n plus 1 by 2 pi by 2, and n belongs to integer value. Okay. And the period, okay, sir, the period becomes here, the period, okay, for, okay, sir, right here, tan x plus pi is equal to tan x. This implies that tan bx plus pi is equal to tan x. Therefore, the period for bx, angle bx, period becomes pi by mod of b. This is the period. Okay, let's draw the graph for the pi. Okay, I will take only pi only. Okay, this is the range. That's the range of this one, sir. The range of the tan x is, the range belongs to r. Here is it has the value of the r, all real numbers. Okay, sir. At pi by 2, it is not defined. Okay, sir. Thus the function, the tan x, okay, sir, the value of the tan x is, this is the graph for the value of the tan x. At minus pi by 2, at pi at 0, it gives 0. At 0, at pi by 4, it gives 1. Okay, this is not defined, and it will be 0 for the pi by 2. Okay, next is function for the cotangent. Next is for the cot theta or cotangent. So graph the cotangent. Okay. Y is equal to cot x. So this is as equal cos x by sin x. Okay, so the domain belongs to R minus wherever sin x is not defined. Okay, sir. Minus, okay, sir, minus 2n pi x n pi plus or minus n pi. Okay. Okay, and n belongs to z. This is not defined. At sin is equal to 0, it is not defined. Okay, this is the function for the cotangent. This is the r. This is the domain. This is the 0. This is the pi by 4. This is the pi by 2. This is the 5 pi by 4. This is the pi. Okay. Domain is, the range is belongs to any real number. is equal to minus pi by 4 equal to minus pi by 2 equal to minus 5 pi by 4 equal to minus pi. Okay. Okay, sir. At 0 is not defined. At pi by 4 is 1. At pi by 4 is 1. At minus pi 4 also is 1. This is a positive 1. This is minus negative 1. Okay, sir. At 0, because sin x should not become 0. Okay, sir. At pi by 4 is defined and pi by 2 becomes 0. Because 0 by anything is okay, sir. 0 by 1 is 0. So this is the function. Okay, sir. This behaves like that. Okay. Yes. This is like that. Okay, sir. If you want to show more turning, more slope, after slope, more slope. Okay. This becomes here. Yes. And this becomes 1. Again, at the pi by 2 it's not defined and pi by 4 is the minus 1. Okay, sir. See, again it becomes here. Okay, sir. This pi by 0 na? This becomes not defined. Okay, cuts here. Similarly, similarly here. Okay, sir. At the pi by 2 it is 0. At the pi by 4 it is 1. Pi by 2 is 0 na? Pi by 4 is defined. Okay, pi by 2 it is 0. So something is missing na? Pi by 4, pi by 2. Let's see the graph here. Yes, sir. This is not pi by 4, it's the 3 pi by 4. Okay. 3 pi by 4 is 135 degree. Okay. Similarly, okay. This is minus 3 pi by 4. At the pi by 2 it is 0. Okay. At the pi is not defined. Okay. At the pi by 2, okay, this becomes like that. Okay. Again, this goes to this is for the minus 1. Okay. This is minus 1, this is minus 1, and this is plus 1, and this is the plus 1. Okay. So this is it should be here only plus 1. Okay. It goes again 0. Okay. It goes, okay, comes down here and goes down here. Any value for the cotangent, just opposite, reverse to the tangent. One you should remember, it is discontinuous at the pi. At the pi it is not defined. At the 0, pi, 2 pi, plus or minus is not defined. We only have to import together. Next one is, next value is y is equal to, okay, secant of x. Y is equal to secant of x. Okay. This means what? 1 by cos x. Here, what is 1 by x? 1 by 0 is not defined. Again, 1 by 0 is not defined. not defined. Therefore cos of 0 means cos of x is equal to not equal to or that not belongs to 2n plus 1 pi by 2. Domain is equal to, so this means r minus 2n plus 1 by 2n belongs to z. Is it for the second theta? Range, but the range is 1 by cos is, this is the range is the range becomes here minus 1 is less than or equal to cos x less than or equal to 1. So dividing minus 1 by cos x is greater than or equal to 1, and 1 is less than or equal to 1 by cos x. 1 is greater than or equal to 1 by cos x. So minus sec x greater than or equal to 1, or 1 is greater than or equal to sec x. This implies that sir y, this is, you can write now, sec x is less than minus 1 and sec x is greater than less than sec x is greater than or equal to 1. Is it? Therefore the range y is equal to greater than or equal to minus 1 or y is equal to greater than or equal to plus 1. Is it? This is the less than, means this is the y is less than or equal to 1 and y is greater than or equal to 1. Yes. Range becomes less than minus 1 and greater than plus 1. Therefore the function becomes here at where 2n pi is not defined. 2n pi is not defined again. This is the range, this is the domain, this is the 1, this is the minus 1, pi by 4, pi by 2, 3 pi by 4 and pi. The range becomes the domain becomes here, the period is, sin x period is period is here. Next it becomes 3 pi by 2 and 2 pi. We will rewrite the periods because energy domain period has 2 pi na. I am taking pi by 2, pi, 3 pi by 2, 2 pi. Similarly, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. At 0, It's cos 0 is 0. Not defined. Not defined. Okay. The range is what is at pi by 2. At pi by 2, as cos 0 is equal to 1. 1 by 1 is equal to 1. And cos pi by 2 is equal to 0 is not defined. Okay. Cos 0 is not defined. So our value becomes here. Again cos pi is equal to cos pi is equal to minus 1. And this becomes here. Okay. It starts from 0, or starts from 1 and goes to the infinity. Okay, sir. Goes to the infinity. Okay. At pi by 2 again. Okay, sir. It starts from 1. Okay, it starts from minus 1. Okay, sir. It starts from minus 1 and goes to the infinity. How should you retain? Okay, this is at pi by 2 is 1. Yes, and this becomes okay. Start from 1. I should write this one. Okay. This becomes, this should be 1 only. This should be 1 and okay. This becomes here this. Okay. And okay, again 2 pi. It is 0 now. It is okay, sir. Here it becomes here like that. I'm writing this one. Okay. Okay. This becomes here like that. Minus. Okay. At the pi by 2 is not defined. Okay. At the pi by 2 is not defined. This is the formula. Okay. Pi by 2. This is the, this should, okay, because this come and go, should this like that. Okay. Minus 1. This should be like that. All are minus 1. Okay, sir. This is minus 1. This is minus 1. This is minus 1. This is the plus 1. All are minus 1. Okay. Minus 1. The second function is, okay, sir, value is y is equal to greater than or equal to 1 and y is less than or equal to minus 1. Okay, y is equal to less than or equal to minus 1 or y is equal to greater than or equal to plus 1. Graph of the second function. Next, graph of the cosecant function. Cosecant function. Next is the y for the cosecant. Cosecant is 1 by cos x. Let us see that. Y is equal to cosec. Cosecant x. Okay, this implies that 1 by sin x. So 1 by 0 is not defined, means sin of, okay sir, x or sin of 0, sin of n pi is not 0, therefore, okay sir, not defined. No? So cos x is cosecant x at n pi is not defined, therefore domain, because domain belongs to R minus n pi, where n belongs to Z. Okay sir. And the range becomes, what is the range? Range, okay sir, the minus 1 is less than or equal to sin x less than or equal to 1. Okay sir. Let's appear carefully. So how to find the range of the function? Okay, so this function, okay, and I'm taking the 1 by, so minus 1 is greater than or equal to 1, okay, dividing minus 1, okay, that is equal to 1 by sine x, okay, that equal to 1. Similarly, okay, sir, 1 is greater than or equal to 1 by sine x. Is correct? Okay, sir. If 2 is greater than 1, so 1 is less than 1 by 2. This philosophy I am applying. Okay, sir. If minus 2 is less than 1, so minus 1 is greater than 1 by 2. That's also I am applying. Divided by 2. Same sign, same here, over only changing the sign. Okay, and this becomes cosec x. Cosec x is less than minus 1. Okay, and this sin x is less than 1, then 1 by sin x is greater than 1. Okay, this is the less than 1. Yes, so this becomes cos x. Okay, sir, 1 is less than or equal to cosec x, means cosec x is greater than or equal to 1. Cosec x is less than or equal to 1 means y is less than or equal to minus 1 and y is equal to greater than or equal to plus 1. Okay, this is the condition, and except the point n pi, and at the pi at 0 it is not defined. Okay, let us see the graph. See the graph for the y equal to cosec x. Okay, this is the R, this is the domain. This is the pi, this is the pi by 2, this is the 90 plus 180 plus 370 plus 360, 2 pi. This becomes minus pi by 2 minus pi. Okay, rest being distance minus 3 pi by 2 minus 2 pi. Okay, so what is the condition? At n pi is not defined. At pi is equal to 0. Yes, sir. At pi is equal to, it becomes 1. Okay, this is 1. This is here 1. Okay, at pi becomes, at 0 and pi is not defined. Okay, sir. So right hand writing. This curve is cuts here only. So okay, let's take some 1 here. Okay, sir, 1 here. This curve cuts, okay, sir, comes to the point pi by 2, again goes to the opposite side. Okay, again at pi minus 1, okay, sir, at this point come to the point, okay, sir, 3 pi by 2 is minus 1, point to the minus and again go to the back. Okay, again, okay, sir, at pi by 2, okay, sir, it is defined, it comes to the point either, again go to the minus, again it comes to the point, okay, sir, 0, okay, for the cosecant x, y is equal to cosecant x with period 2 pi. Okay, then with the period 2 pi, the figure, okay, the function behaves like this. Okay, so this is the sixth function. The range and domain is very important when we driving this course. Again, we will solve the one example. Okay, solve some basic example, one very important. This is the one point here. In physics formulations, came to know oftenly A is equal to sine omega t. Okay, sir, something else. Here I am taking A is equal to sine. Okay, sir, this is sine of cos omega t. A is equal to cos omega t in physics formulation. And this is sine of bx. Okay, A sine to bx. Okay, sir, for bx value, period is, okay, sir, for bx, the period becomes, okay, sir, 2 pi by mod of b, positive or negative. Example I am taking here is equal to, A is any arbitrary value, belongs to R. I am taking 2 into sine 2x. Okay, sir. So this here, A becomes, okay, sir, see, the range becomes here, sin x range, domain becomes, okay, the period becomes 2x, period becomes 2 pi by 2, it becomes pi. This is the period. Okay, so the range is, okay, sir, sine of 2x minus 1 is less than or equal to x, is less than or equal to 1. We want 2x, na? So minus 2 is less than or equal to 2, sin x is less than or equal to positive 2. So range becomes, okay, sir, minus 2 to plus 2. This is the only indicator. With the different I am taking. Okay. Only positive I am taking to form the unification. Okay. This is the valuation. Okay, 0, pi by 2, pi, 3 pi by 2, 2 pi. Again it continues. Okay. Again I will take the long lengthy one. Okay. 0. This is pi by 2. This is pi. This is 3 pi by 2. This is 2 pi. Already we know for the sine, this is the R. This is the domain. For the value, sine gives 1 and again gives 0. Again gives 0. For this is y is equal to 1 sine of x. 1x. Okay. For y is equal to 2 sin x, how it becomes? Okay, this is the one. Okay, let it be. Okay, this is one I am taking. This is 2. Okay, sir. This is, okay, this is, take some letter value. This becomes minus 1 and this becomes minus 2. The phase difference, anyway, only for the calculation making. Okay, sir. For this becomes, okay, this doesn't appear completely. Okay, and here it becomes, okay, this is pi by 4, this may be 5 pi by 3 pi by 5, 4. Okay. This is the y is equal to 2 sin 2x. Very important. Okay. This is the function for, it applies. Okay, this is the function, sine function for the value 2x into sine of 2x. Yes, sir. This period is pi, for this is 2 pi. Similarly, if I taken, okay, I will take clearly. If I taken y is equal to, okay, 2 into sine of x by 2. So for x by 2, the period becomes 2 pi by 1 by 2. This becomes 4 pi. Okay, sir. This is normally for period becomes 4 pi. So 2 pi becomes half only. So this becomes, okay, again, okay, this is the one. This becomes at pi, okay sir. Okay, 4 pi na, at pi is gives one value, okay. This comes here, okay. This is the function for y is equal to sine of x by 2. Okay, the period is 4 pi. Listen carefully here. For the multiplication, the wave becomes smaller. For the division, x by 2, the wave become longer. Okay, sir. In physics, you can call it, this is amplitude, and this is called phase. Okay, sir, or angle. Okay, sir. This is amplitude, this is A, and this is the phase. Okay, sir, understand? This is 2x. This is only x. Okay, and this is for x by 2 with respect to sine function. For all functions, okay, sir, all trigonometric functions, okay, sir, it would be same here only, same relation with respect to their diagrams. For cos, it starts from here and ends from here. Okay, sir. For tan, okay, sir, for tan, it's okay, it's cutting like that. Now it cuts shortly here. It cuts short here. For pi by 2, it goes to here. Okay, for sine, for tan, this becomes sine, a cotangent becomes this one, and the second becomes this one. Okay, sir. This becomes small. For multiple angles, it becomes smaller wavelengths. For divided, okay, sir, the division angles, it becomes larger wavelengths. Okay, sir. This is the brief introduction about the graph of the function 36 trigonometric function. In next class, we will discuss about the sum, okay, the real trigonometric functions, allied angles, okay, sir, sum, positive angles, okay, sir, sum and difference of the addition and subtraction of the angles, sum and difference of the angles, multiple angles, okay, sir, in terms of tan, in terms of cot, okay. In that type of questions we will solve. Real means main mathematical area. This is completely theoretical part only in trigonometrics. Next chapters, next concept are completely mechanical. Practical questions will be start over there. So this is the conclusion. Any ambiguities, any queries here, please comment on the comment box. Okay, sir. This is the remaining is very easy. By the data you can put the graph whatever you want. So this is the concept. Okay, sir. This is the for the normal sin x. This is the for the sin 2x, and this is the for the sin x by 2. Okay, sir. If you understand this one, it really helps to understand the physical formulas, especially with the trigonometric function. Okay, students. I am going to conclude this class. I will meet in the next class. Thank you. Thank you for watching.